Good morning everyone. I am Haoqin Zhao from the Institute of Information Engineering, Chinese Academy of Sciences. Today I will present our work, MMSD 3.0, a multi-image benchmark for real-world multimodal sarcasm detection. In this work, we focus on a common but underexplored setting, sarcasm expressed not by a single image, but through the relationship among multiple images, text, OCR, and visual order. Most existing multimodal sarcasm datasets and methods assume a single image setting. However, real social media posts often contain multiple images, and sarcasm may emerge only from the contrast between them. In this example, the text alone is ambiguous, and the first image alone is also insufficient. The sarcastic intent becomes clear only when we compare the two images. This reveals a key gap. Single image benchmarks cannot fully capture the relational dynamics of real-world multimodal sarcasm. To address this gap, we introduce MMSD 3.0, a benchmark composed entirely of multi-image samples. Compared with MMSD and MMSD 2.0, MMSD 3.0 has around 2.6 images per sample and much longer text, about 31 words on average. We also preserve OCR and emoji information, instead of discarding them, because they often carry important semantic and affective cues. In addition, the data is curated from both Twitter and Amazon reviews, reducing hashtag-based sampling bias and improving source diversity. MMSD 3.0 is designed to better reflect real-world sarcasm. First, the text is longer and more contextual, which makes the task closer to document-level understanding rather than short-sentence classification. Second, many images contain embedded text, such as memes or screenshots, so OCR becomes an important signal. Third, image order matters. Some posts form a sequence, where disrupting the order can weaken sarcasm reasoning. Therefore, this benchmark requires models to reason over context length, embedded signals, and sequential multi-image structure. To tackle this benchmark, we propose SERM, the cross-image reasoning model. SERM integrates four types of information: the post text, multiple images, OCR cues, and image order. The model first encodes text, OCR, and visual features separately. Then it uses positional encoding and masking to handle ordered image sequences. Finally, it performs cross-modal interaction through two key modules, the dual-stage bridge module and the relevant guided fusion module. The first key component is the dual-stage bridge module, or DSBM. Its purpose is to let text and images exchange information both before and after sequence modeling. The pre-bridge performs initial cross-modal attention, allowing the two modalities to share semantic context early. Then, a Mamba-inspired sequential block captures local dependencies through Conv1D and long-range interactions through state space modeling. After that, the post-bridge realigns the contextualized text and image representations before classification. This design is especially useful for longer text and multi-image sequences. The second key component is relevance-guided fusion. Not every image contributes equally to sarcasm. Some images may be central, while others may be less informative or even noisy. Therefore, we first use OCR-guided alignment to connect text-level meaning with embedded visual text. Then, we estimate the relevance of each image using both semantic similarity and a learnable scorer. Finally, the model aggregates visual evidence according to these relevance weights, allowing it to focus on the images most related to the sarcastic intent. Here are the main results on MMSD 3.0. Text-only models perform reasonably well, showing that language remains a strong signal. However, image-only models perform poorly, because they cannot interpret sarcasm without textual context. Existing multimodal methods improve over unimodal models, but most of them are still designed for single-image input. General-purpose MLLMs, including GPT-4o, Lava, and Qwen 2.5 VL, also show limited performance on this specialized sarcasm task. In contrast, SERM achieves the best result, with 85.16% accuracy and 84.42% F1, outperforming the strongest prior multimodal baselines. We further conduct ablation studies to understand where the improvement comes from. Removing the dual-stage bridge or the relevance-guided fusion module causes a clear performance drop, showing that both cross-modal interaction and relevant-aware aggregation are important. Removing OCR also hurts performance, which confirms that embedded image text is useful for sarcasm reasoning. Positional encoding and emoji features also contribute, although with smaller gains. Overall, the ablation study suggests that the performance improvement comes from the combination of all components, not from a single isolated module. To further inspect the model behavior, we visualize attention patterns. The model tends to focus on semantically meaningful regions in the images and important words in the text. For example, when sarcasm depends on facial expressions, screenshots, or embedded text, SERM assigns higher attention to these relevant regions. This supports our motivation. Sarcasm often emerges from subtle cross-modal cues, and the model needs to align text, images, and OCR evidence to understand it. To conclude, MMSD 3.0 moves multimodal sarcasm detection beyond the single image setting and toward more realistic multi-image scenarios. It introduces richer text, multiple ordered images, OCR, emojis, and more diverse sources. On the method side, SERM provides a dedicated architecture for cross-image and cross-modal reasoning. The results show that MMSD 3.0 is challenging for existing models, while SERM establishes a strong new baseline. Thank you for watching, and please refer to our paper and code for more details.